listening to Data Skeptic, Graphs and Networks, the podcast exploring how the graph data structure has an impact in science, industry, and elsewhere. Welcome to Data Skeptic, and sorry for the delay. It's been a while since I dropped an episode, and that's unusual for this show. We're going to get back on our weekly schedule shortly. The fact of the matter is, I have just been swamped. But I went on a hiring spree. We have a new editor, new production coordinator, new director of technology. So I'll be able to pay attention to the podcast and put out the show you guys deserve shortly. We've actually been planning to ramp up the next season of Data Skeptic, partially to blame with some scheduling conflicts. I got one interview that's coming up in a few months that is such a good one, we'll just do it out of sequence. You'll hear the Graphs and Networks music again one day. But no, the new season is going to be all about recommender systems. So this episode is me picking Asaf's brain about how a network scientist looks at this problem. In fact, I've already done a bunch of interviews. I just had a few ducks to get in a row before we could kick this off. So I'm very excited for this season. I should probably actually plan a little break in between seasons. I always feel like these end with no pomp and circumstance. It's like on Doctor Who when Adric died at the end and then they don't acknowledge it. So at least I rope Asaf into this little, let's say, call it crossover or prelude to Recommender Systems episode, straddling both topics. And there's tons more topics, as you can imagine, not just the methodologies of how do recommender systems work, but frontier stuff like federated recommender systems and privacy-centric systems and things along those lines. Tons of interesting stuff. As you will hear when I get into the segment with Asaf, he astutely points out that a lot of the cutting-edge stuff is going on in industry. And don't get me wrong, there's still plenty of researchers out there that I found to interview. That's primarily what we do here on Data Skeptic. If you're actively working in recommender systems, shoot us an email, but there's some conditions. First of all, no CEOs, no C-level anybody. I only want to talk to the person getting their hands dirty. The data scientist, engineer, whatever your title is, the boots-on-the-ground person getting the work done. If you're open to a no-strings-attached conversation, feel free to hit me up. I am most sincerely looking for some industry use cases, especially novel ones. So if you're working in the field and wouldn't mind sharing your work here on this platform, please email me at a special email we've created, RS, as in recommender system, rs@dataskeptic.com. So thank you all for your patience as we've had a spotty schedule, and thanks to Vanessa the most, who's been a real hero in coordinating everything, handling advertisers and whatnot. We're getting back on track, and I can't wait to share with you all the great work I've already heard done for our new season on recommender systems, I guess starting right now. Welcome to another installment of Data Skeptic, Graphs and Networks. I'm joined as always with co-host Asaf, and Asaf, I've got an announcement to make today. This will be the first time the general public hears about this. I think you're about the third person to know, but the topic for the next season is going to be recommender systems.
Why am I only the third to know?
Oh, well, I told my assistant and I told someone close to me, and you're number 3.
Oh, okay.
I should have told the graphic designer first if I was being smart. And, it's funny, I asked ChatGPT to predict the next topic for Data Skeptic, what our next season would be, and it had some really good ideas, actually, one of which was recommender systems, so I guess maybe it's overdue.
Wow, cool. Okay.
And then, of course, so why are we talking about it? I thought it would be interesting for you and I to explore the possible overlaps between network science and recommender systems, pick your brain a little bit on what the opportunities are there, and see if you had any suggestions on research directions we should take along the way as we get deeper into that literature and start to highlight certain authors who are doing interesting stuff in that space.
Cool. So, first of all, the applications for recommendation systems usually in industry. So there's lots of papers about it, but I guess the cutting edge technology is out there.
You think so?
Yeah, I guess. Right. I'm from the academy. I don't want to say hard things, but I guess most of the money isn't there, right? It's not there. And if I understand the current political wave, it's not going to get better. So I guess most of the resources and so on are in the industry. So practitioners bring some
Oh, yeah.
interesting insights, from people who actually work with this stuff. Yeah, so I'm a practitioner, so I really advocate it. That's when we talk about who to interview, but it's actually funny you said it, because I just hung up on another Zoom call with my students who actually are doing a project now about recommendation system.
Serendipity.
When you do a recommendation system, you connect things that aren't connected, right? What are the edges there? I like to categorize it to two parts, like explicit connections, edges, and implicit. So when I look at explicit, I look at edges that there's no argue that that's a network. When we talk, right, we are creating a network. What define these edges? Like physicists would say, we exchange information. Information is an edge, or maybe a dependency could be an edge, and so on. Things that are absolutely dependent on each other. On the other side of the spectrum, there's the implicit connections or edges. That's where recommendation systems kick in, because I like the let's say Marvel movies. Okay, I like Spider-Man and I like Ant-Man. I can assume that I would also like Captain America, although I haven't seen it. So it's what we call a recommendation or a link prediction.
Yeah, it's a link prediction in your mind. Yeah.
That's the kinds of edges that recommendation system work with, right? Implicit edges. Since they're implicit, it's not bulletproof, right? It's not perfect. There'll be some mistakes, and what we tried with this project is try to minimize those mistakes and try to do all kinds of cook the networks, you can call it. Just to give an example, one of the most basic ways to do a recommendation system is using what we call a bipartite network.
Building multi-agent software is hard. Agent-to-agent and agent-to-tool communication is still the Wild West. It's clearly the emerging future, but how do you achieve accuracy and consistency in non-deterministic agentic apps? That's where agency comes in. They have a very clever spelling. Here's how it goes. A-G-N-T-C-Y. I'll give it to you again in a minute. The agency is an open source collective building the Internet of Agents. The Internet of Agents is a collaboration layer where AI agents can communicate, discover each other, and work across frameworks. For developers, this means standardizing agent discovery tools, seamless protocols for inter-agent communication, and modular components to compose and scale multi-agent workflows. Build with other engineers who care about high-quality multi-agent software. See where you can fit in this ecosystem. Visit agency.org and add your support. That's AGNTCY.org. When I talk about online privacy security, I speak from experience as a Delete Me subscriber. What's been eye-opening is watching my quarterly privacy reports show me just how many data brokers are out there collecting our information. In my first report alone, I discovered hundreds of listings containing my personal details. Everything from old addresses to family connections. I'm a low-rent public figure, but I don't want the rest of that stuff out there. What makes Delete Me different is their comprehensive approach. They don't just remove your information once. They keep monitoring and removing it continuously, and they stay ahead of privacy threats. As new data collection methods emerge, their team adapts and evolves their protection strategies. They don't just focus on known data brokers. They're constantly scanning for new sources of data exposure and developing removal processes to address them. It's like having a dedicated privacy guardian working around the clock. Take control of your data and keep your private life private by signing up for Delete Me. Now at a special discount for our listeners, today get 20% off your Delete Me plan by texting DATA to 64000. That's DATA to 64000. Message and data rates may apply.
To give an example, one of the most basic ways to do a recommendation system is using what we call a bipartite network. A network with two kinds of nodes kind A and kind B. Let's call it, in the case of a recommendation system of products, let's call it nodes from type A customers and from node type B products. In this kind of network, the only connections are between nodes A and B. Customers aren't connected within themselves, and so are products. The only connection is a customer buying a product. Okay. In order to understand which product might go with another product, what we need to do is to project the network. That is, to delete the customers and their edges and connect the products by the customers that are linking them. Okay, and then we get a one-dimensional network, a network of only products, and the edges between the products are assumption. We assume that if people bought watches, they also bought necklaces because we see an edge between them. Let's say I bought a watch and I also bought cucumbers on the same buying rampage. Okay, there's a link between a watch and cucumbers, but it was only me. Okay, it was a random decision.
Well, earlier when we were talking about link prediction as an analog for recommender systems, or I guess it is one possible way to do recommendations, and it seems like we can benefit from all of the existing approaches to link prediction. But what about something like node similarity that we might identify you as a customer? And do you think, if you and I were embarking on a new venture, we had no research history to go on, we've got to build from the ground up new recommender system, and we've got to decide where to invest our R&D. Obviously, we're going to put some into link prediction. What do you think about node similarity as a path towards recommenders?
I think what you were talking about is the cold start problem. So you don't have it.
Yes, exactly.
So you don't have any nodes to compare between. So
no, I might know properties of a node before I see all of its links. For example, I have its IP address, so from that I know some geographic information. I could extend that with whatever, maybe I know you from some sort of shady third-party tracking, but I know things about a node before I know all its edges.
if you get it from attributes that aren't network related. Okay, so that's why you interview other people, because I'm a network guy.
Fair enough. Oh, you'd mentioned that the students you're helping are embarking on a recommender system project. What made that an ideal thing for them to study?
Actually, I didn't initiate the project. A colleague of mine got let's say, requests from the industry for projects, and then she referred them to her students. Shout out to Yonit from Shinkar College. What they needed was a recommendation system, but in because they have sensitive data, they didn't want it to to run on the text, to see text or labels or so on. What I suggested is to use network properties in order to create a recommendation system. So we don't need to see the labels, we don't need to see the data itself, only the connections. And by anonymizing the data, we can create a network, project it, or something like that, and give a score for a recommendation.
Well, do you have personal experience with recommender systems? Do you find that they delight you or annoy you?
I guess I sometimes feel I kind of hit a glass ceiling. Where there's when they recommend me the same things, and
You looked at flowers the day before Mother's Day. You don't need to see them 6 months later.
let's imagine I'm a random walker. Okay, I'm traveling through my community and I discover all kinds of things. Okay, and I want some teleporting. I want the recommendation system to take me somewhere I didn't know I need to go and discover me something new that I would like. That's the hardest thing, because if I'm thinking from a network point of view, 80% is within communities. The strong connections, most of the connections are within community, and the weak connections, the connections that take us to a different place, are rare. Weak connections that take us to an interesting place, a place that interests us, are even rarer. So that's the problem. So my solution is, in the case of, let's say, streaming, I do, let's say, a Netflix. I have a Netflix account. A month later, I cancel it and do an Amazon account, and then I do I'm circling around. So that's the random walker of streaming. So that's my tip of the day. Except for Disney, that my children won't let me cancel it.
Well, I've got maybe my third and final thought about how we could apply network science. We talked about link prediction, maybe node similarity. What about something from influencer networks or social networks like using PageRank? For example, I see a lot of books coming out that are sort of about network theory, but some of them are just sort of soft armchair books, like a psychologist wrote it, and it's not necessarily my cup of tea. But if you recommended a book on network science that, as an authority in the area, would convey, I would think, a lot of weight towards a good recommendation for someone who likes the technical literature and the scientific literature.
Yes, that's the whole idea behind PageRank, right? It was created in order to recommend websites. And by the way, I know which book you are talking about.
Oh, then enlighten me. I'm actually not sure. I've seen more than one sort of soft book.
I thought you were talking about Malcolm Gladwell's book about.
Oh,
I think it was the tipping point. I think he wrote it. Yeah,
tipping point,
yeah.
yeah.
The interesting thing is that he hasn't mentioned the word network once in this book, but he's actually talking about degree centrality, between centrality, and so on. I can prove why this book is wrong, but maybe for another episode or.
I would love to do that episode if you want to do a takedown.
Okay. Well, head to head with Malcolm Gladwell. Let's see.
I should read it in between then, so let me make a note. I haven't read it yet.
Oh, he writes. I think he apologized for this book like 100 times since then, but for different reasons, not network reasons. But the problem with this book, I'll just say it in a few words, is when he talks about centrality, he actually talks about personality. You can have all kinds of persons, right? Personas. But the thing is that even if you're, let's say, outgoing and so on, it doesn't mean you're an influencer. It probably says that you have maybe a high out degree, but it doesn't necessarily say that you have a high in degree. When you build your theory of influence on personas are probably normally distributed, right? So you should have a few like this. I think most of us are, let's say, average. But we know influencers are not normally distributed, right? It's a long tail. So by definition, personas aren't supposed to be a big part of what it is to be an influencer.
Well, that's going to be one of the challenges I hope to talk to some researchers about as we start exploring more into recommender systems. So thank you for your advice along the way.